qualities. And remember, there are ways to display them, but they're a little bit different. Now, most everybody had a bar graph on their paper. Did you guys realize that, right? The bars were separated. But a lot of those bar graphs were turned sideways, weren't they? So the bars were doing this. And really, that's because it's easier to read than the bar charts that we do this way. But we do those in elementary school, right? It's a little bit different. And then let me just quickly double check what else I have in here before we go to the note packet. Oh, I can't remember if it was you guys or the other class. We were talking about how it was the day of we did the hot dogs. Remember the hot dogs in the blender and that was gross? Yes? And so there were the vegan hot dogs and somebody's like, ew, vegan hot dogs. But I'm like, well, actually, though, they're so much better for the planet. So these are graphs out of the New York Times, and this is average greenhouse gas impact by type of protein. And you can see that beef has like a 20% impact for every 50 grams compared to things like tofu, beans, and nuts. So, and that's why sometimes people are more down in this poultry and even and fish kind of area, right? Because those tend to have lower fats, and they also also beyond that, it's less greenhouse gas going on. A different type of bar. So these were bars. Pardon me, let me go back here. These were kilograms of CO2, right? So they're quantities, but they're done as bars in an organized way. This is a bar that's been broken up into pieces, right? So this is the cost of a pair of sneakers imported from China. So there's the materials and labor. So that's not quite 50%. There's the manufacturer margin, so how much money they're making for profit, shipping and logistics, and then there is tariff. All right? And so all those things go together to make the price of those shoes $26. So the price to the consumer, however, might be closer to $145 because it includes all the other markups. So this kind of goes back to the fact that we have a lot of tariff issues right now, especially with our good friends Canada and Mexico. So, and then the last one I pulled from the New York Times was, this is another type of bar chart. It has some chronologic stuff to it, but it's Michael Jackson versus Taylor Swift and each of their albums, like how many platinums they went, right? These types of graphs are the ones that tend to be out there more often. You guys don't open up TikTok or any sort of news area and look at box plots, right? And you don't see back-to-back 7-leaf plots. You sometimes see histograms. You see a lot of timeline data, right? And then you see a lot of these bar charts comparing things. But you can see the disadvantage of this one bar being so tall, although it's kind of like, the world's tallest building, right? It's there because it's obnoxious. It sticks out. But here, notice, okay, one thing about the bars. Do you guys see how these bars are going up and down, up and down, up and down, up and down? It's because they're on a timeline, right? And so they do have an organization. But a lot of the bar charts that you guys had out were organized like this. The longest bar was on top, right? And then it went down that way. Now there's a special name for that. We call it a Pareto chart. It's just a special type of bar graph that's organized to make it easier to read, because we go from the most important, the biggest guy, to the smallest guy. And then we can also add a line graph to it, kind of like an ogive, actually, which makes it another kind of interesting thing. There's this whole, when we display categorical data, there's a lot of different ways we can do it. Data that still has numbers in it can be organized in a two-way table. So that's a whole separate lesson. That's lesson 9. You did them in 8th grade. You did them again in Algebra 1. You might have revisited in Algebra 2. Who knows? But then other ways we can do it is pie charts, lots of different styles of bar graphs. So there's all sorts of ways we can stack bars. We can turn them horizontal. We can make them vertical. And then the thing that's kind of like your skill is making a Pareto chart. So that's kind of I need you to realize that, like, as you answer questions and do these skills in this unit, this is the skill that's tested. When we move on to pie charts, pie chart is a circle. It's divided into sectors for each category. So then the area of the sector is related to the frequency of each category. So while we have our circle, and this is why we don't draw them by hand, because can anybody draw a circle really well by hand? No, we all stink at it. But basically, the way it works is, like we find out the total, right? The sum. And so in our calculator, we would be able to get that pretty easily by getting the sigma, right? And I'll just give that to you because I'm here for you. It's 3007. And then each part of the pie is a percentage, right? So for example, let's make sure we understand what this is about. This table has types of degrees that were given out, that were conferred, were awarded in the year 2007. And this could be a fairly large university, maybe. I don't know, maybe a medium-sized university. So that year, during the graduation ceremonies, they did 728 associate degrees out of 3007. So when we take that, right, 728 out of 3007, well, what the heck does that mean? I'm going to take that and find its percent, which is going to be 24%. But then even beyond that, that we can estimate is a quarter of the pie, right? But if it's like a weird percent, then you have to figure out the degrees and this and that. But that's how pie charts are made, is like, oh, this is going to be associate's degrees, right? And then we break up the pie considering. But we always use technology to make those because they are a pain in the tuchus. So guess what we're going to do? We're going to let our calculator make this. Are you ready for fun? This is the fun part because our calculator can do it. It's got a couple of extra steps, but it's not difficult at all. So you're going to want to open up a table just like we did before. And that's a 4. And our first column is going to be degrees. So I'm actually going to type the word degree. And our second column, you could say, is frequency, how many we gave away. Okay. And then feel free to abbreviate. An associate's degree, if you don't know, is typically a 2-year degree. And not every program has an associate's degree available, but a lot of places have those offered, and they can get you enough educational that you can go and get a job with just an associate's degree. The next thing is a bachelor's, and I'm just putting a couple letters in. That's your typical 4-year degree. A master's, which is what every teacher is required to have, is typically 2 additional years beyond your bachelor's. There are programs out there that let you do like a 4+1 to get your master's, so you can get your master's and your bachelor's in 5 years. It just kind of depends. So like I have a master's in math, science, technology, education. I also have my teaching certificate. So like it's a whole bunch of wax. Then there's the first professionals. I'm just going to put PROF. And that could be it's like that could be a lawyer or a doctor, like their special degrees, and that's additional education varies. And then the doctoral is actually a PhD. So the idea of I can get a PhD in math, I can get a PhD in English, I can get a PhD in just about anything, right? You have to do a doctoral thesis, so on and so forth. Okay, so have you guys heard of most of those? Yeah, good. Okay, so now you're just going to type in your numbers if you haven't done so already while I was yapping. Oh, that's wrong. And so it wouldn't make much sense to run one variable statistics on these numbers, with the exception of to get the total. Does that make sense to everybody? So that's why we would not run, so 1, you can't find the average of words, and 2, even if I found the average of these 5 numbers, well, what the heck does that mean, right? These are quantities. So now that we have these, this is the fun part. So now you're going to add that page. And so it's control doc or add a page, and you're going to go and add your 5 page, which is where you display things. And you should have the words floating around, right? Okay, So we do have to still click the x-axis, and we're going to put degree, and they're going to float down. But this is where it's a little bit different. If we were to put the other thing on the y-axis, that's like a scatter plot, right? That's like coordinate pairs, like I'm going to plot 1, 5, right? So we don't want to do that. So under menu, you, I believe, want to go to plot properties, which is 2, and where it says add Y summary list. You guys see that? Number 9. Add Y summary list. So we go down to that and we hit enter, and you want it to be frequency, right? And so as soon as you do that, what did it just make for us? Made our bar chart, right? Our bar graph. And it's not an organized bar graph. Like it's not a Pareto chart because they're not in order, right? It could we do have the ability to have it organized for us, which is kind of cool. But we want a pie chart. So we're going to go back to menu. Is everybody doing okay? Okay. Go back to plot type. And now do you see how everything is gray except for pie chart? That's the only thing it's letting you do until you press 9. And there it is. What's kind of nice about this, I'm just going to escape to get out of this, is now that when we hover, do you guys see that you can see percentages? Like it'll automatically calculate your percentages for you. It gives you a strong visualization of half, quarter, and then the other 3 together are a quarter, but then like really masters is almost like a good, 20% on its own. In fact, like I just guessed that, and there it is. And you can see how small these are. All right. So having our technology make this is so much nicer. So actually, let's just see something real quick. I'm going to go back to my, here we are, intro to stats. And then we go in here. And let's see what our data is looking like in our warm-up. So remember, the thing that's cool about this is that it does start to do stuff with your responses. Right? And so it's not going to make histograms or box plots of these responses, right? And didn't we see some of the numerical data that tried to do crazy things and it didn't make any sense? But it really does a nice job with these kinds of things. All right, so now down here, how satisfied were you with Halloween? A lot of you like the top responses right here. You guys, so this one doesn't do as nice of a job, but we could probably take that information and put it in a spreadsheet and do something with it to then figure out like a Pareto chart that would go with that. Okay. All right. So we're good with the pie chart. Oh yes. What's wrong with this pie chart? Look at it carefully. Can you figure it out? It's a really interesting, 3D version of the chart, right? Versus a flat pancake. But what's wrong? What looks weird? What percent of sales were in Q1? 38. What percent of sales were in Q2? What percent of sales were in the third quarter? 38. And what about fourth quarter? 20. Hey, the sales were equal in Q1 and Q3. Does the pie chart 3D really support that? It doesn't. Like your brain is trying to fix it. Does that make sense? Your brain is really working hard. Compared to, isn't that much clearer? Yeah. So making a pie chart in 3D, while it looks great, it could be in USA Today or what, like you don't want to make displays that deceive, right? So being in 3D, this makes the sectors look different. And our brain can't change it back to 2-dimensional well enough. The sectors are the pieces of pie. So these two do not look equal. This looks like it's the biggest quarter. And maybe there's something about third quarter earnings that are really important, like they're trying to get people to invest in their company, right? Look at our third quarter earnings. They were amazing. I don't know. There might be a reason behind the deception. If you go back to the very beginning of the year, we spent some time doing that, and our friends in Congress are really great at doing that all the time. All right, so now bar graphs. We're going to save bar graphs for the next class, and we're going to focus on Pareto charts for the remainder of today. There's a video to watch for bar graphs. It takes about 15 minutes to watch it. It's about the stop and frisk program, which is sometimes used by different police forces, depending on the situation. It kind of actually parallels some stuff that's happening with ICE currently in the news. So it does have a sensitivity measure that I want people to be prepared for. But it just does show how we can make bar graphs of different types, stacking versus non-stacking. All right, so here goes our Pareto chart. So this one displays types of medication errors in, like, maybe in a hospital given a year, okay, or a nursing home. I don't know where, I can't remember where the data was collected from. But it says here, a Pareto chart is a bar graph in which the height of each bar represents its frequency or its relative frequency. So remember, frequency can be a count, right? Versus relative frequency can be either like a decimal or a percent, okay? So it can do either. It's totally up to you what you think serves your purpose. Okay, the bars are positioned in order of decreasing height, and that's so your eye is drawn to the top 3 or 4 choices, okay? With the tallest bar positioned at the top or at the left, right, because we read from left to right, then the line, so that's part 1, right? Now the line is actually almost like an ogive. It's cumulative relative frequency, okay? So now let's kind of take a look at this to see what's going on. So medication errors. This is frequency, right? So I can see that we've missed doses 92 times. That was the most frequent mistake. Then the next thing was giving a dose at the wrong time. And then 76 times giving somebody the wrong drug. Okay. Then we go to an not overdose, like I've overdosed and passed out or whatever, but just too much medicine is an overdose. Giving it to the wrong patient, wrong route. Wrong route would have to do, I think, with oral, topical, IV, some of those ideas, I think was what route would be considered to be. Wrong calculation is got to do possibly with percentages within a medication, how it's given within like an IV bag or something like that. Duplicating drugs, an underdose, wrong IV rate. Oh, there's the IV rate, and I'm not sure what rest. Maybe you have to give rest in between or something like that. So the thing about this is we can clearly see, I don't know, my eyes are definitely drawn to the first 5. Would you guys agree with that? Like, there's a fairly dramatic switch from the top 5 to the bottom 5. Okay, so your eye is drawn, and this, once again, the reason why they're going this way is because isn't it easier to read words this way than underneath the graph? Okay. Then the next part is looking at the cumulative relative frequency. So they have the total number, somebody added these all up, right? And then they calculated the percentages. So a missed dose happened 21% of the time. Does that make sense to everybody? Then another 20% was at the wrong time. So now this is my cumulative. Does that make sense then, how these are working? Okay, so as we move up through the graph, so the first 4 is now 72%. So this is like 72% of errors are these top 4 reasons. And then this is what one of the values of this chart, and this is it goes with the 80%, 20% or 80-20 rule. So what you can do is you can go, so they have another axis bar here, right? For cumulative frequency. And so 80% of the errors, and so it's kind of weird, but you can actually draw a line over here, and you can see that 80% of the errors are essentially caused by those first 5 things. And so when we get down to the bottom, it says the chart above is visualizing insights into the most reported medication errors in an unnamed healthcare facility. Missed dose, wrong time, wrong drug, overdose form the 80% of the errors reported. So proactive healthcare crisis management teams should focus on the 80% of the issues to resolve. So this then gives people a priority list of what needs to change, what needs better monitoring, what's going on, how can we fix our problems. Like, we are not worried as much. I mean, these are still terrible things, right? But these are the things that we need to focus on if we're going to, like, get our rating back up or get an approval from an accreditation organization, right? It helps us focus our energies. Okay, go ahead and turn the page. So we are going to create a Pareto chart with the time we have left, and we might not get through the whole thing, and that's okay. But basically, you would be given data, and your first job is to just look at it and figure out what it's about. Then you have to figure out what goal you have. Your goal is a Pareto chart, so then what do you have to do to the data to make that happen? So let's take a moment here. It says every year the Better Business Bureau receives complaints from customers. In a recent year, the BBB received the following complaints. Okay, so just take a moment to read through those. You don't need me to read through about those 5 things. And now our first goal is to organize, right? That's just a random, maybe the list came into us alphabetical, right? Well, alphabetical isn't helpful here, right? We want it to be organized from the highest number of complaints, or the most complaints happened here, to the least complaints were about this, right? So what topic or what type of business had the most complaints? Our auto dealers. Okay, and I'm just going to go ahead and write the number in there right now, 14,668. All right. Then our second one was about auto repair. Okay, and that was 9,728. Okay, so then we keep skimming, and it looks like the next one is home furnishing stores. So if you're thinking about home furnishings, I tend to think of places like Ashley Furniture, possibly an IKEA if we had one, something different like that. Then we have our computer and computer service. And then our last one, and this is so not relevant in today's life, is dry cleaning. This is so out of date. It's great. Do you guys know what dry cleaners are even? Okay. So like, you guys do not, like, your parent, my dad would have to get his suits dry cleaned all the time. And then like my mom would press his shirts, like, you know what I mean? But like, if you didn't want to get your shirts, if you didn't have somebody to press your shirts and you didn't press your own, you would send them to the dry cleaners. They do your laundry, press your shirts. You'd be looking good with your suit and tie. Because he would have to wear a suit and tie every day. Because they even had casual Fridays back then. No casual Friday for you. None. Okay. So now that we have them in order, we can start to make a bar graph. All right. So down on the bottom, we're going to make it tall and going, like, we're going to make tall bars. All right. So are going to put our categories down on the bottom, and I just want to make sure I label my notes correctly. Where did I put my notes? There it is. Sorry. We want to make sure that on the bottom, actually on the bottom, we don't have to put a label because we're going to do the individual businesses, but we can draw a line. It's just not like a number line. It's just like a nice little line. We're going to have 5 bars. Bars have to be equal width and they have to be spaced out, right? So for the bars, they're equal width. They have spaces in between. Let's see, spaces in between. And then once again, we're going from most to least. All right, so I'm just going to skip this first box, and it works out well to make them about 3 wide. That way they're not obnoxious. So I'm making a bar that's 3 wide, and underneath here, I'm just going to write auto dealer. It's small print. It's all good. And then you can actually skip 1 box, or you can skip 2, whichever you find easier to work with. Especially if you have big handwriting, you might want to skip 2. So I'm just going to skip 2 and mark off another 3. And this bar, when we draw it, is going to be for auto repair. Once again, now I have to be consistent. I am skipping 2, making a width of 3. This one is going to be for home furnishing. This one is for computer, sales and service. And then my last one is for the dry cleaners. So people complain about the dry cleaners because you have to take like things like your wedding dress to the dry cleaners. And if that gets ruined by the dry cleaners, that's why dry cleaners were like a frequently complained about thing. Because if you ruin somebody else's clothes, there's no going back, kind of a thing. Okay. All right. So now we need to create a different axis for frequency, right? The count. So we're going to do our basic frequency for each one, and we're going to count by the thousands, right? So our highest one is 14,668. We need to get up to 15,000 somehow. So let's see what works. It might be, we're not using much of the graph, but that's okay. Frequency. 5, 10. I think it's just if you make each line 1,000, we're not going to go up super high, but that's okay. Or that's not bad, right? So I have 0 and then 1, 2, 3, 4, 5. This is 5,000. Are we cool? This is 10,000 complaints, and then 15,000 complaints. And so we might title this Better Business Bureau Complaints. So you can still see the idea of title, tick, tick, label, 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 right? And now we can go ahead and make our bars. So you're just going to estimate 14,668 is just under 15,000. All right? So go ahead and make your 5 bars. And even though it's still just 5 bars, and the associate degrees we did were just 5 bars, the types of degrees that were awarded, it still is really nice to have it organized. Our brains process it faster, right? We can make better comparisons. It's just a nice way to do it. Now, the other axis is going to take a little bit of work because that needs to go up to 100%. And these axes don't need to actually be up at the same height. We can make them any way we want. So if we want this axis, for example, to go up to 16 blocks, then we can break it into 50% in that, right? So if I draw an axis over on this side and I go up 16 blocks, which is just one higher than the 15 that I have on the other side, I can make this 100%. And then this axis is now relative frequency. And I'm just going to then break it down into 4 is going to be 25%, 8 is 50%, and then 12 is 75%. And what time is it? We have 5 minutes left, about 5 minutes. Okay. So to be able to do this side, I'm just going to help us out with some calculations. We all know relative frequency is part over whole, right? So our whole was adding these all up. These are our pieces that we have. This is 35% right here. And let's just make this cumulative instead, cumulative frequency. So we're going to accumulate. So because auto repair is 23%, this is going to be 58%. Okay, so we're going to accumulate. Then 76, then 90%, and then 100% at the end. Okay. So now this is where it's like its own separate graph, like lying on top, and this is where it definitely differentiates from an OGI because you're not connecting parts of bars at all anymore. So at the end, we want to be at 100%. So let me just change to a red pen. At the end, when the dry cleaning is done, we want to be at 100%. Since this is 3 wide, I'm going to like the 1.5 mark, and I'm just going to make that dot right there. Does that kind of make sense? At the end, that's where we're at. So now let's go back to the beginning. In the beginning, auto dealers represented 35%. So this is 25, that's 50, this is going to be 42. No, I didn't do that right. 37. So the halfway point is right around 37. So right about here, I'm going to put it right about here. There's our 35%. Does that kind of make sense? Okay, it's not great, but we're just going to go with it. We got then to 58%. So this is the 50% line. We're just going to go up a little bit. Here we have our 58%. I'm just going to put it at the top of the bar. Then we go to 76%, which is right above the 75. So that's going to be super easy. Right about here. And then the last one was 90, which is going to be right about here. Okay. And then we just kind of go ahead and once again kind of draw a line that's connecting these. Once again, that one's really hard to do, and that's why we have computer technology that can make these beautiful graphs for us. But once again, what's kind of cool about this is that we can kind of be like, oh, if I even go at 75%, my top complaints out of 5 categories, which these are not really great categories, fall or whatever. Why do you think there's so many complaints about autos? This really quick. Why do you think people make such big complaints about cars? Price. Okay, what you get for the price. So think about it. When you get a car, that's a pretty big investment, correct? Okay, so first of all, if you bought a car, especially if you buy a used car, right? And there's a lot more things out there now to protect you. And New York State even has something called a lemon law. Have you guys heard of that? Like, you are protected. If a dealer sells you a lemon, they have to refund your money. Like if they sell you a bad car. So there's complaints about that, but then there's all sorts of complaints about dealership or repair places because, man, I need to keep this car for 10 years because it costs so much money and I'm paying for it for 6 years. You know what I mean? Like, there's this anxiety we have about our cars because it's like our lifeblood to get from point A to point B. So we have a lot of feelings about them, which is why we tend to complain more when things go wrong. So there's a lot of psychology in this as well, which is kind of interesting. All right, yes, if you don't mind cleaning up on your way out, that would be super awesome. I don't have any homework for you today, but like maybe go back and look at this sometime before Wednesday to be like, what in the world did we learn about it? Because it's always nice to know.